Hello, I'm Peter Harrop, Chairman of IDTechEx. We have an interesting stand here. We're going to interview the Fraunhofer Institute and they'll introduce themselves.
Hello, my name is Peter Spies. I'm with Fraunhofer Institute for Integrated Circuits, and we are showing here different energy harvesting systems. So we're using, for example, thermal gradient to power state-of-the-art electronics just with the heat of the human skin. Our focus are microelectronic circuits, so we're developing DC-DC converters optimized for thermal harvesting systems. Here you can see a Bluetooth wristband which is poorly powered by the heat of the human skin. We're measuring the temperature and the acceleration in this wristband and transmitting the data to the tablet. The whole wristband is solely powered by thermal harvesting.
Cool. But can you make this smaller? All this, what's next?
We are working on that. So the next version would be a lot smaller, and of course we want to integrate that completely in the textiles to have fully self-powered systems.
Can you power ARM Cortex M0 Plus or some? What's MCU? Is there an MCU? How do you make the Bluetooth work?
The Bluetooth is completely powered with thermal harvesting.
And the microcontroller?
Yes, of course, everything. Right. But the microcontroller is not the problem. The problem is the power amplifier to transmit the signal. It consumes the most power.
All right. So how soon can we get this kind of stuff in all consumer electronics?
This one here in a couple of years.
Couple of years? We get a smartwatch with no need for battery?
Yeah, I think so.
Just works by putting it on.
A smartwatch is a little bit more than that one. That is just the Bluetooth. The smartwatch has a lot more. It has a display, it has some more processing
But you
power.
could have some sensors, you can have step counter.
Yeah.
Which other sensor can be powered by skin?
Yeah, sensor, step counters, temperature sensors, acceleration sensors, humidity sensors, everything.
Some concern with piezoelectric harvesting that it's not very reliable. Do you find that?
It depends on the frequencies and on the acceleration you're using. If you're not stressing the material too high, then you got no problems.
You're okay.
Yeah, so it depends always on the frequency. In that one, we're just using 50 Hertz. So typical application would be a railway container, a motor, or something like that, and then we work in the frequency range between 20 Hertz and 70 Hertz, and that is not so high, and so the reliability is okay, I think. It will endure several years or tens of years.
And is there a way in which that is better than an electrodynamic answer from Japanese or...
Electrodynamic is that one here, and electrodynamic is a little bit cheaper because the components are cheaper, but it's more bulky, and the electrodynamic things are not so easy tunable. So you always have to tune your vibration harvester to the exciting frequency. And this is done very easily with piezoelectric. You can just move the mass on the cantilever structure, or presently we're working on other technologies to tune the harvester during operation. For example, with magnets or with...
I see. I was going to say, if you go off the resonant frequency, you then get reliability problems. Yeah. But I suppose the challenge is with all energy harvesters, vibration harvesters, is to have a broad acoustic bandwidth. It's a challenge still, yes. And you're working on that?
Now we're working not on improving the bandwidth, but tuning the harvester during operation. So some kind of self-tuning system.
Can chase. Right, I see. Good, thank you very much.